This section of the course is all about data visualization in Matlab. The importance of being able to visualize data and visualize equations cannot be understated, particularly for debugging and testing and evaluating new code. Matlab has a really powerful visualization or graphics engine, and I'm going to introduce you to some of the capabilities of that graphics engine over the next several videos. I'm going to start just by showing a bunch of cool looking pictures. These are all pictures that I got from the MathWorks website. MathWorks, of course, is the company that produces Matlab. So this is just to give you a bit of a taste of the kinds of visualizations that are really straightforward to produce in Matlab. Now I'd like to start with a motivating example. So here's a formula, and I can tell you this is the formula for a Gaussian function. Now let's say you want to implement the Gaussian function in Matlab. So the question is, do you know what this function looks like? Do you know what the graph of this function looks like just from looking at this formula? Now, if you've taken a calculus course, then you can probably guess the general form by considering how it behaves at the limits, how it behaves close to zero. Maybe you want to try looking at the derivative. Or maybe you're familiar with this formula from a statistics course. So this is a Gaussian, which is also sometimes called the bell curve or the normal distribution. But this is a relatively simple function, and it's a well-known example. There are more complicated examples that can be more difficult to visualize just by looking at the equation. So let's say we want to implement this function in Matlab. So here I have attempted to translate that formula into Matlab code, evaluated for t from minus 0.5 to plus 0.5, and for s some arbitrarily selected value here. Now I can run this code, and I don't see any error messages, there's no warnings, there's nothing. So it doesn't seem like we've done anything wrong. Matlab didn't indicate that we've done anything wrong. However, if we were to plot the result, then you can see this probably doesn't look like what you would expect a Gaussian to look like. In particular, if you look at these values here, these are all really close to 1. In fact, the smallest value on the plot here is 0.9998. So this is all essentially 1. Now it turns out that the problem here is that we need to add some parentheses to make sure that the order of operations is correct. So all of this term here, so 2s squared, that needs to be separated, or grouped together I should say, and separated from the numerator from this division sign. So now when I run this code again, I'll press Control Enter. Now you see this looks quite different. We go from 0 to 1, and we get our expected looking Gaussian or normal curve. So this is just an example of the importance of data visualization to make sure that your code is correct even when Matlab didn't produce an error. Okay, so that is just a motivating example about visualization. For the rest of this video, I want to introduce you to the basic concepts of visualization, in particular the parts of figures that you can visualize. So Matlab graphics are displayed in these objects called figures. Now I like to have my figures docked. You can have your figures undocked. Let's see, so here we have undocked, so now the figure is in a separate window from the rest of the desktop. So I like to have them docked. So I'm going to press this little down arrow over here. That's going to dock them. And then, as I showed in an earlier video, you can move these figures around. Maybe you prefer to have the figures on the left. It's totally fine. This happens to be the way that I prefer it. Now, a data visualization is not actually drawn directly in the figure. The figure window is all of this light gray window that you see back here. And what you see in white here is a particular axis. So you have an axis that is inside a figure. So I'll show you how that's spelled. Axis. So we have a particular axis that is inside the figure, and then the data, the graphics, are actually drawn inside the axis. This is showing one axis in the figure. You can also have multiple axes in the same figure, and I'm going to show you how to set that up in a few moments. Okay, so you can type the word figure and that will open up a new figure. So now I have figure 1 and figure 2. Now notice there is no axis in figure 2. There's nothing drawn in figure 2. So that's why this has this white area in here where the plot is drawn. I didn't actually say to visualize anything. I just said to create a new figure. Now I'd like to close this figure. Obviously, you can click on the little X here and that will close the figure, but you can also type close. Now, I type close here, but there's actually two figures that we've created here. So how does Matlab know which figure should be closed? So Matlab is not necessarily going to close the most recent figure that was open, and I'm going to illustrate that to you now. So the most recent figure that was open was figure 2. I'm going to select figure 1. That makes figure 1 the active figure, the most recently clicked or used figure, and then I type close, and then that closes figure 1. So when you type close, Matlab will close not the most recent figure that you've created, but the most recent figure that you've been working with, that you've clicked on, that you are interacting with. Okay, so this will just create a new figure, and it gives them numbers according to increasing integers. So it starts at 1, and then 2, and then 3. Now, if you know which number figure you want to create, then you can use that as an input into the figure function. So this is going to create 3 new figures, and those will be numbered 10, 100, and 103. This can be pretty useful if you want to show data in a specified figure. Okay, so then you can also use close to close particular figures. So I'm going to write close and then in parentheses 3. Now that is going to close figure number 3, which is this one. Now this is different from how I called close here, because here this closed the most recently interacted with figure. I'm now interacting with figure 103, but I'm going to write close 3, and that closed this figure in here. So we no longer have figure 3. Here I'm showing you that you can separate a line of code in Matlab with an ellipse, so 3 decimal points here, 3 dots. So that just allows us to continue a line of code onto the next line in the script. And after the 3 dots, you'll get all comments. So this is showing how to close multiple figures at the same time. So now 2 figures just disappeared. All right, so that is how you create figures, and that's how you close figures. To plot, you can use the function plot. There's actually many different ways to plot. There's plot, and there's bar and image and contour and surf. There's all sorts of ways to visualize data. Now this plot actually went into figure 10 because that was the most recently interacted with, or recently clicked figure. So don't worry too much about how to set up the inputs for the plot function and so on. There's going to be a whole video just dedicated to this plot function soon. Okay, so then to close all of the figures, you can type close all, and you see that got rid of all of the figures. Okay, so that's the basics about opening and closing figures and numbering figures. Now I'm going to show you subplots. So far we've been putting all the data into one axis in the figure. And what I'm going to do now is show you how to create multiple axes inside the same figure. This is obviously useful if you want to show different kinds of data from different analyses or different observations in the same figure, so they're easy to compare. So the key function that we want here is called subplot. And subplot takes 3 inputs. The first 2 inputs tells Matlab about the geometry that you want to create axes in. And then the third input is for which axis should be the active axis that you want to start working with. So for example, subplot 1, 2, 1 means that we want a geometry of 1 row and 2 columns. So it's going to be one figure here, or one axis here and one axis here, 1 row and 2 columns. And then we're going to start working with the first axis, which is going to be the one here. So run this line, and here we get 1 axis here. Now Matlab didn't plot another axis here because we didn't request one. We didn't say yet that we want to work with this. And then, I'll just plot something in here. Okay, and now I'm going to type subplot 1, 2, 2. So notice the first 2 inputs are the same here and here, so the geometry is the same. Except now we are going to be working with the second subplot, the second axis, and that's going to be over here. So that you see there. Now, if you have fewer than 10 subplots overall, so fewer than 10 axes overall, you can actually omit the commas in the inputs and just provide one input. This is initially a little bit confusing because it looks like we are entering the number 122. But in fact, Matlab recognizes this as a special case. This only works for the function subplot, and it only works when you have fewer than 10 subplots in total. So 3 by 3 or smaller. So then Matlab will parse this 122 into the same inputs as this. So there you go. And then we're just plotting some random numbers. Doesn't really matter. Okay, so this is for a constant geometry. We can also mix the geometry here. So let's close the figure, open up a new figure. And here I'm creating a subplot geometry of 1 row and 2 columns. And we're going to plot these numbers, these random numbers, into the first subplot here. Now I'm going to change the geometry. This is a different geometry from this. This is a 2 by 2 geometry, so it's going to be 2 up here and 2 up here. And the question is, and then we're requesting the 4th axis, so we're going to be drawing into this one. The question is, what is going to happen with this subplot here? Is Matlab going to delete this axis from the figure because this thing here is not consistent with a 2 by 2 geometry? This is drawn from or created using a 1 by 2 geometry. Let's see what happens. Okay, so that was pretty interesting. So Matlab didn't change this at all, and it gave us a new smaller axis down here. And then, we can plot some random numbers in here. But there's a but over here. It is possible that you will get, that Matlab will delete this axis here if the new subplot geometry is inconsistent with what already exists in the figure. So this new subplot was consistent with this because they don't overlap at all. But here I'm creating a subplot that is 3 by 1. So that means 3 rows. So there's going to be one subplot here, one subplot here, one subplot here, and then only one column. Now that means that the third subplot, which we're requesting here, is actually going to overlap with these two axes down here. So then that actually does get rid of those two other axes because Matlab is not going to draw this axis directly on top of the other axes. Now, in fact, there are more advanced ways of interacting with and creating multiple axes in Matlab that will allow you to plot axes directly on top of each other. This can be useful for overlapping, for creating layers of an image, but that's a little bit more advanced, and we're certainly not going to get into that in this video. The last thing that I want to show you is embedding subplots and plotting into a for loop. So what I do here is call figure 1. Now we already have a figure 1. So in fact, this doesn't create a new figure. All it does is make figure 1 the active figure. So when we draw, we're going to be drawing into figure 1. Now in this particular example, because we only have one figure open, then this line of code actually doesn't do anything. But if we have multiple figures, so let me open up a new figure, a new figure, a new figure. Now there's 4 figures here, and figure 4 is the active figure. Now if I call figure 1 again, that's going to bring Matlab back to figure 1. So just to illustrate this further, I can write figure 2. That brings us to figure 2, and so on. Okay, so bring our attention back to figure 1. And here I'm using CLF. Notice this is pretty similar actually to CLC. I already introduced you to CLC, which clears the command window. And CLF is it's conceptually similar, except we are clearing the figure. So here is a non-empty figure. We type CLF, and now we get a totally empty figure devoid of any axes. Okay, so now I'm creating a subplot geometry. It's 2 by 2, and then we're working with, at every iteration inside this loop, we are working with the subplot 1 through 4 according to the location here. And then, this is just some random little equations, not terribly interesting. It's just to highlight that we can embed these subplot functions and plotting inside a for loop. So in this video, I talked about the Matlab visualization graphics engine. I showed you some examples of what MATLAB graphics can do. I gave you a motivating example to show the importance of visualization for evaluating the accuracy of your code. And I talked about MATLAB figures, opening and closing figures, and subplot geometry. In the next video, we're going to have a cute little exercise that's going to show you how to give you more experience working with subplots, and in particular, take it a little bit to the extreme. But I think it'll be fun and educational. See you soon.